Hi, I'm Pete Kozachik, a first-time home builder. I'm just starting out on my first project, and I'd really like to invite you along for the journey. My first inspiration for the project was my granddad. To my young eyes, he seemed to be capable of making anything. As a teenager back in 1909, he amazed the town of Lapeer, Michigan with a horse-drawn glider, and later on, an airplane powered by a Model T engine. For my plane, I chose to modify the better-suited Corvair engine instead. To begin with, I found two usable engines made in 1964 and in 1967, and that's where I'm starting the project. Typically, those engines were covered with 40 years worth of oily crud, probably keeping rust at bay all that time. Today we're going to disassemble the 1964 engine. This engine was living in a van its whole life. We're talking about 40 years. And given that it started out in 64, I like to think of it as a hippie van. The 1967 engine was considerably different. It lived in a Monza, which was considered at the time to be the hot rod version of the Corvair line. This guy, the 64, is destined to become the organ donor to the 1967. The head studs, well, a few of them came out on their own, and then I chose to take a couple others out as well, and you're not supposed to do that. There was also some issue in the Monza engine with the pushrod tubes. These guys are great, they're absolutely pristine, but the ones in the Monza, they'd been mangled with a pair of vice grips. Anyhow, it's weird economics, but it's actually cheaper to take this engine, this $50 engine, and use it as an organ donor, so that's what we're going to do. Well, I found another clean spot in the garage, so here's where we're going to do the disassembly. First thing up is the 8-finned oil cooler. That's not enough fins for the job, so it is going into the recycling bin. I need at least this one exhaust log, this one here, because I didn't have that one on the other core motor. So we're bending down these little metal tabs first that hold down the keepers, and then we're breaking the nuts loose, and I guess it's been since 1964. That wasn't so hard. Since 1964 that this thing was last dismembered. This particular piece of sheet metal doesn't look like much, but it is a crucial part of the job, and it will end up back on the airplane. Yep, indeed, this is part of the baffling, the cooling system. Look at that. Maybe it was a hippie van. Looks like this skid plate did some major skidding in its life. It's like this thing is not going to have to be pried off. What the heck was going on down there? Looking good. So this thing here is the Delcotron adapter. This stuff has to go out too. This is the push rod for the fuel pump that we're not going to use. So that's gone. And now I'm going to take off the rear oil accessory cover. This thing. Going to save all this hardware, it's going right back. And this piece too is going to be used. I didn't really think that was going to come off that easy. Moving down to the bottom here. This one wanted to stay on a lot more than some of the others. maybe we can wiggle it right off. Yes. On the bottom of the rear accessory oil cover are a couple of things I need to get the inside parts out of. That's the oil pump and this pressure regulator. We'll do the oil pump first. And there are the gears that comprise the oil pump. So here's the driving gear, and here's the driven. The oil pressure regulator, it's got a bunch of stuff in here that need to come out before we go to cleaning. And starts with this plug. And right behind it is a spring. Maybe I can just reach in there and grab it. There we go. And then behind that is a little plunger side. There we go. So I'm going to follow some advice and keep the rocker arms paired up with the balls that they've been living with in storage until I or somebody else has some use for them. And of course the push rods, they're perfectly good, so I'll be saving them. Okay, so they get saved in their own little bag as well. Okay, so the rocker arm studs are coming out as a pair, and along with goes the push rod guide. And that's pretty much it for what comes out of the head. Well, this is my first attempt at welding 4130 alloy, and how very coincidental that it's being used to tap out the push rod tubes rather than mangling them with vice grips. And it seems to work pretty well. Super well. I quite like this. I've been looking forward to this, quite honestly. Great. So all I've got to do now is take off these O-rings on both ends, at least on that end, and these guys will come right out. And lo and behold, I hope, she comes right out. Excellent. So this is the oil cooler housing coming off with a couple of bolts. There we go. Okay, this is the top cover. The top cover has to come off before we can do any more work with the pistons and the connecting rods and all that, so we can get at them. So off it goes. This, by the way, will not be reused. And there's the crank. So next order of business is to take this head off and see what's going on inside. Okay, we're just finishing up checking the braking torque, and so far they've been in the 30s, like this one, which is great. So I'm feeling pretty good about this. See that? It's coming off. It's not pulling the stud out, which is magnificent. So far anyways. It does get a little tight towards the end. I think I'm going to have to run these things down again and brush off whatever's going on in those threads. Not this one. Or this one. Okay. What I thought was going on the whole time was that we were spinning off the stud nuts like I'm doing here, but in fact one of them stalled on some corrosion. Now, I didn't see that because of course it was covered up with a socket. So eventually it stuck out so far that I took a look down by the case, and sure enough, we were backing it out of the case itself rather than taking the nut off. Sure don't want to kill it now. So we're just not getting the separation from the cylinders and the head for whatever reason. I tried everything that I thought wasn't going to quite break something. So solution, I think, is we're just going to pull the whole thing off and deal with the cylinders themselves separately instead of en masse. Okay, well, for what it's worth, there it is. I guess we'll get these cylinders off any way we can. Okay, cylinder baffles, these are really in good shape. Remarkable. Make sure that the cooling air actually does get to the bottom side of the cylinders. Well, this head behaved a whole lot better. It's separated from the cylinders quite easily. It's a good thing. And slides right off the head studs. And there's our eagerly awaited first view of what's going on in the combustion chambers. I'm adjusting the crankshaft, as you can see, to get the best bite on these rod bolts. Well, this one's an easy one, so we'll go ahead and break it there. Okay. And now for the not so easy one, that's way down here. And we'll find just the little magic spot that I can actually grab it and get some movement. I guess that's going to be it. Okay. And breaking it. All right. This process takes a lot longer than it looks. It's a very finicky job getting these rod caps off. But we got ourselves a complete assembly now. Just making some room, getting the crankshaft out of the way. There we go. So come on out. So it's the whole assembly. Cylinder, rod, etc. It's a boy. Okay, we're going to lose the oil pickup. This is going to go straight to William Wynn. He's going to do a deeper version of it because there's going to be a deeper oil pan. So first up, we're going to take off the bell housing. Most of it's going to become scrap metal, but a certain portion of it is going to be cut out. I've already done this once. Actually, I'm probably not going to do it again. Basically, this piece is cut out of the rest of it and is used as the front of the engine, and the propeller hub will be right out here. Voila. So these are the case bolts that hold the case together. Okay. Don't worry, you won't have to sit through watching all these things come off. Who'd have thought? So like everything else, we're saving the hardware, including all these case bolts. So we're going to take this case now and split it right down the middle so we can get at the crank and the camshaft that are down in there. I'm going to go easy on it first off using a rubber mallet only to separate it. There's really nothing but pins holding it together, so let's just give it a try. That's a fine thing. Comes off real nice, feels precision. And there they are. Pretty much the stars of the show, the crank and the cam. This cam, well, it's a core, and likewise the crank, so we're going to keep those. But what we've really been looking for, actually, are the two case halves and their lovely little head studs. How's this for a transformation? The case is back from its cleaning and it's looking real good. Brian, the guy who runs the shop, checked the main bearing alignment. Just gave it a touch with a hone, so there's going to be a very straight bed for the crank to lie on. Well, the crankshaft's been on a journey of its own. Brian initially gave it a Magnaflux test, and it passed, showing no cracks. He followed that with a 1010 regrind, taking the main and rod journals down 10 thousandths. He also dressed the grinding stone to enhance the fillets. It's important in avoiding stress fractures. Then he tapped the crank to receive a William Wynne safety shaft. It'll pass through the propeller hub, taking the thrust load so the crank flange doesn't have to. Next, I shipped the crank out to Nitron Incorporated for what they call an ion plasma nitride treatment. It strengthens the crank against stress failure. Here's the crank before nitriding, all polished and pristine. Afterward, it looks like this. The dark stains are normal to the process. After that, Brian gave it a check for straightness and another Magnaflux test. As a final touch on the crank, the new distributor gear needs a press fit. But I'm not set up for that, so it's into the toaster oven at 350 degrees. Slick. Well, here's our little problem stud. The story got uglier when the stud seized while I was testing it for reinsertion. It came out real hard, and as you can see, it dragged out with it this major chunk of aluminum. Well, that pretty much mandated using a helicoil, which is what you see here. Those studs have some unusual threads on them. They don't fit regular threads, but they can be made to, otherwise the helicoils wouldn't work with them. I did an experiment on one of the mangled studs from the Monza and found out you got to be super careful not to overdo it. Only way to go is with an adjustable die cranked open so it doesn't take a big bite. The studs are pretty tough. On advice from several veterans, I used a brand new die and took it easy. Finally got to a point where it felt like if I tried to drive it in the last third of the way, it'd be a problem to get out. And another stud turned out to be loose. I was checking them with a torque wrench, very gently of course, and this guy moved at 15 foot-pounds. Well, I'd dearly love not to have to use this gimmick, but just in case something goes terribly wrong in the installation of a head stud, I want the option to be able to back it out. So the idea here is to clamp down nice and tight, like that, and back the stud out without damaging these threads. Well, I got this clever little gizmo from Clark's Corvairs. Basically what it's for is to grab the top of the head stud, and it enables you to torque it in. You can grab it here with your torque wrench. Of course, you want to be able to get it off also. So what they do is they supply this steel ball that goes in there, and it keeps everything from seizing. You can see I'm monitoring torque all the way down. Most advisors say 10 to 30 foot-pounds is ideal. More than about 35 and you can weaken a stud permanently. Sure enough, it got tighter right near the end. And the eagle has landed right around 15 foot-pounds. That gizmo didn't want to come off, at least not with any torque I was willing to put on it. Even tried warming it up with a blowtorch. Well, I think I've got a way to get this thing off without doing any serious damage to the head stud. And so, what have we done? A good thing or a bad thing? Let's just see. I'm hoping to see a ball with a few scratches on it, but nothing else. Come on, baby. Well, sweet. Okay. I borrowed an idea from Richard Finch and threw together my own version. It's made of 2 rocker arm studs. You can torque it down and then loosen it with a pair of wrenches. It doesn't seem to need the ball, just a tapered down end on the bolt. No problem going in. Torque is okay. Got tight near the end, around 15 foot-pounds too. Well, the installation gizmo had gotten pretty tight but loosened up just as advertised. Thanks a lot to Mr. Finch. There's a lot of good info in his books. We've got to do some polishing before we go into clean room mode. It's these holes. Specifically, it's the surface that contacts those O-rings, the ones that were on the pushrod tubes. There's a few small but important jobs left to be done, and when they are finished, this thing's going to be ready to put together. That's pretty cool. First job has to do with the mating surface here. Got to get all the burrs and snags off of it so that when we do put the other half of the case together, it actually does fully come together. Here's a spooky one. Going to check clearance on the rod bearings. It'll be easier access now with the crank right out in the open. These bearings are matched for the 10/1000ths that Brian ground off the crank. Brian gave me a clearance reading, but I want to do it myself, mostly to try using Plastigauge. Never used it. Looks like it would be kind of an interesting thing to try. So this is a piece of Plastigauge. Doesn't look like much. It's the green version. That's calibrated for a range between 1 and 3/1000ths. I'm expecting to get a clearance reading a little under 2/1000ths. 15. And there's 20. Brian's reading was 00175. And this result looks very similar. Now I'm going to go check the rest of them. From here on out, this is going to be off limits for dirt, inside and out, especially inside. Can't forget the oil gallery plugs. I was kind of surprised when Brian said to use aviation forma gasket. Seemed sort of low-tech with all the dialed-in thread lockers out there now. But he said I might want to get them out someday. This is the second of 2 cams that I've tried in here. The first one had a little bit of a bend in it. There's nothing that you could actually see, but on each revolution I would encounter a certain little drag. So this one's running real good, and that allows us to move on. Excellent. Yep. Checking clearance on the main bearings. Last check before assembly. Plastigauge says all 4 bearings hit right in the middle of GM's spec. Just making sure everything's nice and clean. Yes, we're going to use the 50-50 mix as our primary assembly lube. I also wanted to use some of this stuff because it's been highly recommended for having graphite and molybdenum in it. So I'm just going to add a little extra bit of that too on everything, especially including this thrust bearing here too. And hold on, I'm going to come right back in with the stuff that we already know about. It's a goodly amount of it there, which is fine. So that ought to be good. We can move on to the next. Some more of that moly graphite. And some of our famous 50-50 mix. Should be a happy crank. And we can plop this, or gently place this into the motor. And when I say gently, I really mean gently. Taking my time. Appears to be in. Nice, 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 nice. It's very smooth. It's very straight. It's great. This is some sort of a seminal moment. Coming up on that special moment where we try to synchronize the cam and the crankshaft. I think I've done my homework here pretty well. Let's see if I get it the first time. Both gears have a little timing mark on them, and it's up to me to get them to line up. Oops, I'll try that again. I think that might be it. I'm going to do some special checking and just make sure. This is the lube that came with the camshaft itself, and I've since checked it out on the internet, and it's very well received, so I'm quite happy to use it on this one. They must know what they're doing. One thing, it doesn't have any molybdenum in it, and I thought you're supposed to always have moly on these things, but well, I guess they know what they're doing, and I will just use it. Just screwing things down for when we're torquing at 55 foot-pounds so this thing doesn't move around on the table. Kiss him goodbye. If all goes well, we won't be seeing these two again. I'm following William's advice on prepping the case bolts. Silver anti-seize on the threads and form a gasket on the bolt heads. That's to keep oil from oozing past them. Same with these new grade 8 nuts and washers. I had to use smaller washers to fit the spot face area on the case, and also had to enlarge their holes. Torquing was intense. Like, can these bolts take it? I mean, are they going to break? I figure there's about 37 tons of tension on these bolts. But it was hugely gratifying to get to this point with all that prep that's been going on. Next thing would be to put in the pistons, but I need the crank to move nice and smooth for a whole new operation. Remember this thing I cut out of the bell housing a while back? Not going to use it. Instead, I'm installing Dan and Jim Weissman's 5th bearing. It's an experimental safety device addressing basically the same concerns as nitriding does. You know, you've got a massive gyroscope in the form of the propeller, and under certain conditions, it puts a large bending load right on this area. It's been known to break, and it's just here that the breaks have happened. Well, a number of people have wished this flange could be made into another main bearing. It would work with main bearing number 4 and take all that bending load between them. These little jaws in the back of the hub, they're there for adjusting out the runout that might be in the end of the crankshaft. So on we go. And I've been trying this over and over again, and it is kind of tricky, but not too tricky, to get those little jaws to actually not interfere with the installation. And a lot of it has to do with what I'm doing here with this Allen wrench. You just got to push them forward so that they don't actually do their job just yet. Okay, that was not as difficult as I thought it was going to be. These little hold down spacers are going to be in play while we're adjusting the runout on the hub itself. There we go. Right now it's loose in terms of the little jaws, so it could move, but not very much apparently. So here's the dial indicator, and you can see that I've got it feeling the edge of the hub. I'm going to rotate the hub from the back of the engine here, and we'll see what we got. As you can see, there's some work to be done. Dan Weissman suggests that we have less than 1/1000th of play here, and there's quite a bit more than that. Well, adjusting runout turned out to be quite an exercise in Zen. First I measured runout in 6 positions on the hub. Based on that, I made a little tweak on one of the adjusting screws. Just kept on doing it, getting closer each go-around. At some point, I got the sense I'd hit the achievable limit. Well, 3 hours later, I've gotten the runout down to this level. You're watching the dial indicator with me turning the crank at a rate of about 1 revolution per 3 seconds. And it appears to meet the specified runout. Anyway, it's the best I could get. The hold down spacers will temporarily immobilize the hub when I've got them torqued down to 15 foot-pounds. With the hub immobilized, I'm taking out the adjustment screws one at a time to coat them with red Loctite. Then I'm torquing them down to 15 inch-pounds. There's only one screw loose at a time, so the little jaws won't get loose. This homemade torque wrench is based on a long 1/8 inch drill bit. I think it's good for a maximum of 20 inch-pounds. I calibrate it with weights on a lever arm. Works fine, just set me back the cost of a drill bit. There's 2 of these plugs. They'll be drilled later to pin the housing in position. Just making sure the plug isn't sticking out at all. I can see daylight under the razor blade, so it must be good. These plastic shims are going to keep the bearings centered around the hub while we're attaching the housing. They're all the clearance we've got in there, 1/1000th of an inch on top and bottom, and even less on the sides. Now that's going to be the thickness of the oil film too, which is pretty remarkable. Once this anaerobic sealer goes on, we've got about 20 minutes to get the job done. Notice there's no gasket. The sealer does the whole job. Has to go on super square, it won't go on at all. feels pretty good. Quick spin these guys in. I'm going to make this nice and parallel. Pretty much what the guys suggested would happen. There's a little bit of a overhang there, but it ain't much. Snug. Snug. And snug. Should be able to move all these shims. Okay, that one moves. That one moves. That one moves. All the shims are moving. Well, when I rotate this, not hugely, but okay, it's a good sign. And we're going to torque this thing. First a pattern here, going up to 15 foot-pounds. There's 5, and 15. Okay, next thing to do here real quick, take these two things, which are the same shim values as the ones that are in here, and feel around in there. The idea is to make sure that there's still enough clearance for oil all the way around the hub. Do you see it going in?
Yeah, I'm not seeing it bend.
Okay, you're not bullshitting me. You can actually see it go in.
Yeah.
Okay, because you're going to be the first one to ride in this thing.
I'm looking forward.
Good. I can feel the gushiness of the assembly lube. Oh, okay, well this is great. This is working out. It's easy. It's easy. Okay, party's over. Now we can get on to pinning the housing to the case. Dan and Jim included some nice drill guides in their installation kit. I like their neat little tool for driving the pins in straight. Well, Jim Weisman counseled me over the phone on how to actually get this oil seal on. And what I'm using here is a 16th inch piece of welding rod that's been ground to almost a point. And we'll see if this trick really works. This is kind of similar to things that one does to get a tire onto a rim. Still spins, that is a good sign. Very nice. Dan and Jim Weisman, thanks a lot. This is great. This is going to be really great. We're going to be doing everything in groups of 6 for a while, starting with installing these beauties in their respective cylinders. The pistons are forged and the rods have been balanced. Hope you like the paint job. It's called cast iron. That's a real color made by Duplicolor. It's supposed to be good for 500 degrees. This is regular motor oil, not assembly lube. I have to measure the gaps in each piston ring and mate them with the actual cylinder that they're going to live in. This is just to make sure the rings are level in the cylinder when I'm measuring them. As I understand it, the gaps will just about close up when the rings are heating up, and we don't want them to run out of room to expand. I'm getting all my numbers from an original Corvair shop manual, actually printed in 1965. This jig you're looking at is something that William Wynne details in his manual. And basically the purpose of it is to make sure that you get the pistons put in the right direction. They have a left and a right hand side, so to speak. So we're going to let it sit right there while we install the piston rings, starting on the bottom, the oil rings. By the way, that little arrow does have something to do with something. In our case, it points to where the propeller is on the engine. But there's a lot more detail in that. If you actually want to do this, then I would suggest checking in with William Wynne on his video and on his book, because that explains it all and it's quite important. Here's the lower of the two compression rings, using the tool that William Wynne has actually suggested. The chrome moly ring, the one that goes on top, there we go. Snap it in. Now this is our 50/50 assembly lube. Well, I've got a couple of these already inserted into their cylinders, and I gotta say this is not the easiest part of the job so far. Got this compressor, this ring compressor, and yes, it's supposed to squeeze those little rings nice and tight so that they'll shoot right past the gap and go all the way down into the cylinder. Just hasn't been working out all that great for me just yet. God. Well, okay, that's typically about where it lands. Hey, that's not bad. Okay, I take it back. Everything I said right here. The top ring has gone most of the way in, and over here it hasn't. I can actually push it in with my thumbnail, and I'll bet I can pull it down from below or something. Yo, I think we're there. The application of the human fist. Certainly want to have this thing documented. Okay. I am really not a big fan of that ring compressor. I'm just trying something here. I got the cylinder upside down. This very convenient little slot here. It could very well make doing it with your thumbs a valid technique. Because look, there's the first one. It's in. Isn't that nice? I think I'll do the last one like this too. Well, I've had this safety shaft for quite a few months now, and finally today's the day that we're going to actually install it permanently in the engine. Had a chance for some more welding practice, making this extra big version of Richard Finch's Easy Off stud installer. Not what you'd call pretty, but I was struggling to join those two nuts without trapping the bolt. This Neanderthal version of a fifth bearing is there just to make sure I don't put any bending load on the shaft while I'm torquing it in. Not really sure about how torquing this giant stud is going to go, so I'm just trying to lose at least one more variable. Okay, bottomed out, start torquing this thing to supposedly 100 foot-pounds. That's it. Look at that, it comes right off. I'm checking the length of these studs. They shouldn't stick out past the propeller hub, not even a tiny bit. They're called hybrid studs as they have special General Motors threads on the end that goes in the crank flange and regular 3/8 24 threads for the hub. William Wynn makes them. This easy-off installer died after a couple of uses. The coupler was just too soft. So I ended up reusing the one made out of rocker arm studs. This will protect the bearing hub's alignment till we have it all clamped down by the prop hub. Now's the time to safety wire these bolts, as they'll be harder to get at later. It's my first try at safety wiring, and I'm getting directions from the FAA Accepted Methods book. I didn't really want a starter on the plane. The idea of hand propping just seemed to fit the whole Golden Age style of project, but I'm putting on this starter gear anyway. It'll be safer. Okay. Check and run out in the radial direction and the axial direction here, before and after torquing down all the hardware. Those blue and white markers are my torque pattern. Basically two triangles like a Star of David. Tighten one triangle, then the other. It's the most balanced I could come up with. And we're back with the Neanderthal rig, putting 100 foot-pounds on the safety shaft nut. Total radial runout is 2 thousandths. Runout on the hub face is 5 thousandths. Now I'm advised I can actually shim the prop to compensate for that. Well, I knew this day was going to come. We're actually poised to start attaching these guys to the crankshaft. However, everything I'm hearing about these rod bolts has them being by far the most heavily stressed bolts in the whole engine. So I double-checked my wrench with this cutting-edge calibration rig. I got the idea for a cheap but precision weight on the internet. Just buy a gallon of bottled water and have the meat guy weigh it. This one came in at exactly 8.57 pounds. So I did a little math to work out where the oddball weight should actually hang on the arm. Well, the whole idea is to load the wrench with a given torque based on where I hang the weight. Then we see if the wrench is actually reading out that value. Well, my wrench was pretty close. It shows about 1 foot-pound less than it's really putting out, so I'm just compensating for that. Well, before these babies go in the engine, ARP, the bolt manufacturer, wants 4 or 5 dress rehearsals, torquing them down using their special lube. It reduces friction, so we're working closer to the same conditions as when they came up with the torque specs. I chose to use copper sealant on these copper gaskets just to ensure no oil leaks, but won't be using it on the head gaskets. Would have been better off not having the rod sticking so far out of the cylinder. Now I have to push it back in to get access for wrenching. Got to make sure the bearing didn't slide out when I was doing that. This is more finicky than it was taking them out. Access is bare minimum down below. I ground down this socket to a tapered thin wall socket so it could fit into the spot face on the rods. Otherwise it wouldn't be able to completely cover the nuts. Just found out that ARP has a new spec for Corvair rod bolts. As of 2009 it's 32, not 25 foot-pounds. Marks on the wrench are calibrated for 30 and 32. I'm aiming in between those two. This is a pretty critical operation and I'd considered using a bolt stretch gauge, but William Wynn pointed out that it's pretty tough to use in these close quarters. Definitely looking more like an airplane engine. Totally bitchin'. So why am I taking the cylinders back off? Well, later on down the line I got a little contamination in the heads. Taking them off for cleaning required replacing the copper gaskets, which is definitely a bummer, but it led to discovering a better ring compressor. It's much easier for a neophyte like me to use, and it comes apart, so I could leave the pistons in place and just remove the cylinders. You can fine-tune the friction right to the point that you can just use finger pressure to get those cylinders back on. Check this out. Need I say more? There's a couple of things to prep before we install the cylinder heads. One thing, you have to install the cylinder baffles before the heads, so this is the time to paint them. That's high-temp engine enamel. It's easier to use than ceramic, but not as heat resistant. Remember this? Well, it's evolving into a high-volume oil pump now. Dan suggested I do this because he wants to make darn sure that his fifth bearing does not get starved for oil. First thing, you replace the idler gear shaft with a longer one. I used the toaster oven again to expand the bore so I could make the swap. Now, here's the original idler gear. The higher volume replacement gears stick out quite a bit. So the kit comes with a spacer. It gives the gears extra room, but it really has to be super concentric with the gears, just like the fifth bearing. The instructions call for wrapping the gears with tape to help center the spacer. It feels like the tape is just filling the clearance, not too tight. So I'm trying it with the spacer too. It's still a good fit. You have to keep checking while snugging down the spacer so it doesn't bind. I've got it torqued down enough that I can drill and pin the spacer. Feels smooth with the tape off. Now we're checking top clearance with Plastigauge. Depending on the reading, you can use one or another thickness of gaskets. If all these clearances aren't precise, the pump won't actually deliver any more oil than the original setup. Got new parts for the oil pressure regulator from Clark's Corvairs. It was a perfect fit. Just in case, I safety wired the plug. Same thing with the crank seal. I used lithium grease inside and out so it would go in easy, and the crank won't destroy it when it first starts up. That gasket is sprayed with copper sealant. I'm using it on most gaskets. Blue Loctite. I'm using it on most assemblies like the oil cover. Now that the oil cover's on, we can put on this new harmonic balancer. Gotta have that marked later on when we're adjusting the valves and the ignition timing. We're going to need it all set up with an accurate mark for top dead center. To find top dead center, I have the number 1 cylinder rigged with a dial indicator. There's some ambiguity, as top dead center is where the piston changes direction, going very slowly. To be more accurate, I'm coming at it from both directions. I'll stop a couple thousandths before it gets ambiguous. Marking the position on the starter gear. And we continue moving through the area where the piston changes direction and stop as the dial returns to the same 2/1000ths mark. The midpoint between both tape marks should be exactly top dead center. So I'm rolling the crank back to the center position. That white painted notch needs a punch mark to line up with. And we have our top dead center. Last thing before installing the heads, I'm painting the pushrod tubes. I'm using high heat ceramic paint. There's a lot of overspray, so I'm wet sanding them. I figure if they're smooth, they won't pick up so much dirt. The paint requires an extra high temp oven treatment, higher than the toaster oven was made for. So I put in a switch to bypass the thermostat. No, it's not safe, but I kept an eye on it the whole time. First time, the paint peeled due to radiant heat from the quartz heater elements. The fix was to hide the paint from direct exposure and only let hot air circulate around the tubes. If I had to do it again, I'd just have them powder coated. Mark at Falcon Machine did a great job on the heads. That included replacing all the valve seats and guides and resurfacing the gasket areas. He also milled off the carburetor flanges and replaced them with aluminum tubes. That's to fit with Williams' intake design. First up, we're going to put in some shiny new valve lifters right about here. They're hydraulic, and there's a specific note in the manual about where to lube and where not to. I'm using cam lube on the bottoms and regular oil on the side. They drop in nice and smooth, and I discovered that they can drop right back out too. Shouldn't rotate to the other side until the pushrod tubes are in. The cylinder baffles go back on very smoothly. Nowadays, these O-rings are made of a synthetic called Viton, not rubber. Had some wear marks I didn't like on the rocker studs, and Larry Shapiro just happened to have some original unused ones in his eBay store. What you don't see here is the addition of extra lube under the rocker studs. Theory is that they have more friction than the stud nuts. Since we're using the same torque on both, it should help equalize bolt tension by making the rocker stud friction more like stud nuts. I got that from a couple of experienced guys, and I'm using the advice, but I wish there was something more concrete to go on. From what I hear, they just used motor oil for anti-seize at the factory. No torquing going on yet, just getting things in place. Later on, I swapped out these large washers for smaller ones, which turned out to be a big mistake. Flipping it over and getting the other side ready for torquing. This operation had some surprises, and I hope someone gets some value out of it. I noticed that the stud nuts were not holding their torque as well as the rockers. I could turn a rocker stud to a certain torque setting and hold the wrench in place, and the reading would slightly go down. The little guys, the stud nuts, would lose their torque a lot faster. I could hit a setting and then have to slowly chase it just to keep the reading constant. Sort of like running in place. First thought was I'm killing something, maybe pulling a stud out or stretching one out of shape, or maybe the nut's giving up. Well, Mark talked me down off the ledge. He said the soft copper gaskets were slowly squeezing down and would eventually bottom out. And the stud nuts, with their smaller footprint, were concentrating more pressure on the aluminum below, making it settle more. Same force was on the small washers and the large guide plates, and that gets compounded by difference in friction. As predicted, things eventually bottomed out. I had to check and adjust torque hourly, then overnight, and finally after a couple of days without disturbing things between checks. Remember I took off the heads to deal with some contamination? Well, I found that the small washers had just given up the ghost. Brian said to replace the nuts and washers with these bad boys from ARP and flatten a larger area for the big washers. My drill press table wasn't necessarily square enough or big enough, so I set up one that was. The table is supported on 3 jack screws. I just tweaked them until the dial indicator read the same at all 3 positions. This counterbore cost a fraction of having a machine shop do the job. And it was fun. Since the drill didn't have a slow enough setting, I turned it by hand. Kinda hypnotizing. The new hardware performed much better and held its torque more like the rocker studs. There's several opinions on how to mount the engine for working on the valve train. I picked Williams. Access just seemed a lot better with the engine standing on its nose, and I could eyeball each lifter directly. But just for safety, I left the hoist in place. There's a very helpful section in Williams' video, all about how to adjust valves so they're good for the life of the engine. During the process, you refer to the top dead center mark to make sure the valves you're adjusting are closed. In broad strokes, it's got nothing to do with torque wrenches. You have to become the valve whisperer, feeling and wiggling the rocker arms as you tighten them down. I found it helpful to listen as well. Ideally, you do one group, then spin the engine a full turn. That puts the other group in place for adjusting. I ended up rotating the engine for each valve at a time. Then you spin the engine a dozen or so times to wipe off extra cam lube. Then fine-tune your adjustments. An additional partial turn puts the plungers in the hydraulic lifters right where you want them. And then a dozen jam nuts top it all off. I have to trim the dipstick tube so it'll be above the oil surface, otherwise internal pressure could blow oil out the tube when the plane is at altitude. This oil pickup is modified to reach the bottom of Williams' deep sump oil pan. I'm being ever vigilant with the safety wire, including right here. These studs replace the original oil pan hardware. And the nuts are light but strong. I hear they're called Mexican hats. Can't imagine why. Last touch is a safety wire on the drain plug. So at this point we've got a long block. I'd call that a milestone. Well, all right, I've been looking forward to this part. We're going to start putting on a bunch of external parts, starting with this alternator. This is the John Deere unit that William Wynne recommends. It uses permanent magnets, a safety factor. We're going to modify these bracket pieces to fit this particular engine. William sells them on his website. The smaller bracket's going to be held by a couple of fifth bearing bolts. So I have to get them out temporarily. Just to make it a clean job, I'm loosening the Loctite with a little heat. The main bracket's going on temporarily, so I can mate it to the small bracket. I like to use super glue to make sure the clamps don't slip. Once the drilling's done, I'll scrape it off. Had to file off a little clearance here. Trying to ensure the two pulleys are lined up so the belt doesn't wear too fast. Williams sells a starter kit too. Installation is similar to the alternator. You line up the brackets and you do a little cutting to make things fit. This piece keeps the starter from bucking under load. It's usually bolted down with a cover bolt. I prefer it be welded on the cover. I ruminated over whether to replace the stock oil filter adapter. It's quite workable, but Williams' version has some advantages. It's got ports for oil temperature reading, a smaller oil filter, oil pressure reading, and an external oil supply for the fifth bearing. This will be my first time making an oil hose. I got the pieces at the auto parts store, and a helpful guy at the counter showed me how to do it. This collar goes on the hose all the way so you can see the hose up against the inside of the collar. Then the fitting threads into the rubber hose, squeezing the rubber up against the stainless steel outer skin. That makes the pressure seal. So there's one end going on to the fifth bearing. That's a little forma gasket in there. I was later advised that it's not necessary. You can see where I smoothed down the alternator bracket where the hose would rub on a square corner. At this point, I can make an accurate cut on the other end of the hose. I'm trying to just cut the stainless with the abrasive cutter to keep the bad stuff from getting into the hose. The idea is to make a clean finish cut with a sharp knife in the rubber hose. That hose put up quite a fight. Same assembly on this end, but with a straight fitting this time. All the stuff that's going to be on top is here temporarily. I gotta find a clear spot to put the oil filler hole. There was one on the stock oil filter adapter, but that's gone now. There's where the oil's going to go in, with a little room for a spout. The last minute design was made with the help of the drill press, a 2-inch wood disc, and some sandpaper. Jerry Beeler, a work buddy of mine, did the TIG welding. Now we can install the new parts permanently. Jerry managed to weld that tab on without it shrinking down. The hole is still right where it's supposed to be. Broke out the AN hardware, as this assembly is for real. Starter alignment tests good. And there you go. The stock breather port is long gone, so I'm following William's advice to adapt a valve cover for the job. Had to redo these welds, as I wasn't using a neutral flame. Very much a beginner at gas welding. The tube with the elbow in it, that's where the crankcase vapors come out. The short tube's going to take in returning oil from the air oil separator. That's yet to come. Very satisfying getting to this point. I was going to set the engine aside at this point and begin work on the airframe, but with a new job and relocation suddenly on the horizon, I decided to finish the engine, right up to the point of a test run. That would require a test stand, and I sketched up a design that would ride on a Harbor Freight trailer. This would be my first major project in gas welding. I started on the lower support frame, as it would be more forgiving. Well, sure enough, I didn't use a neutral flame on most of that phase. I ended up redoing a lot of the welds after a kindly senior welder showed me how to do it right. Definitely get the EAA welding video if you're looking for a good example. These tabs stand in for fittings that join the wooden fuselage to the motor mount. As it happened, they warped too much, so I replaced them with bolt-on versions. That rectangular steel piece is a William Wynne motor mount tray. I'm building a jig that holds it properly oriented to the tabs. There's going to be 7 tubes made of 4130 alloy connecting the tray to the tabs. The jig itself needs to be accurate. Holes in the right places, everything square and true. So, it ended up good, within a 1/16 inch throughout. So, the first motor mount pieces to make are 4 tubes with large clevises on one end. They're going to bolt between the tabs. I'm starting with just one, a full dress rehearsal. Trimming the flat stock was a lot easier with that jig. The design calls for a bend in the flats, and I'm going for a large radius, as you can see. There's a tube spacer for the clevis flats. Without a lathe in the house, I'm getting a pretty square cut with this setup. Starting with a single weld should make it easier to set the gap for the tube to fit in. And there's the fit. I drilled and reamed after welding so I could get the holes concentric. I'll probably have to ream it again after the upcoming welding. Need a notch in the tube to get it up against the spacer. I tried a hole saw fish melting rig, but it's limited and takes too long. For me, this seems to be the best way to go, even though I make several trips to the grinder to get it right. Looks like a good fit. Well, Richard Finch calls for emery cloth on 4130. No sandpaper, no wire wheels. It's a lot easier to gas weld when the flame's set right. Having Williams' tray for a reference was quite valuable. Lots more to come after this tack. Before starting on the real clevises, I sliced up the practice unit. The cross sections looked okay, with some room for improvement. Needed some extra beef here and there. Now we've got 6 tubes all ready to weld. After tacking the parts together, I did the welds in place. That was very helpful. Must have been why there was no excessive warping. When you're in it, the whole process is very primal, melting steel parts together. It's mesmerizing. Your entire focus is on the puddle, controlling the heat, looking ahead. I was glad I could reposition the work. It's a lot easier to work right side up. Well, just in case, I put a few gussets on strategic points. The 7th tube, the diagonal from here to here, that's to resist torque from the spinning propeller. Beware of what you see on the internet. I referred to an internet photo for placement. Well, it turned out later that it conflicted with where the carburetor wanted to be. William specified this placement, which makes more sense anyway. That 4130 is strong. I lowered the engine down on the motor mount, and the frontmost ends of the mount deflected less than a 32nd of an inch. When I lifted the engine off, the mount sprung right back. No plastic deformation. Brian's Magnaflux test of the mount was invalid, as I'd welded over some welds. So I'll use it on the test run only. Later on, I tested the mount with more than double the engine weight. For a mount that was going to fly, the weight should be considerably higher. Marked positions with just the engine at first, plus the empty case it was sitting on. Then loaded up with bags of pea gravel. It's cheap. Just for the torque resisting tube, I added an offset bag. That applied about 250 foot-pounds of torque. There was about a 1/16 inch of deflection, and it went right back to zero when the weights came off. So we passed with flying colors. To top it off, let's mount the engine with urethane shock absorbers. There you go. Yes, indeed, we're starting on the instrument panel. Not for the plane, it's for the test stand. Some parts come from aircraft spruce, like the throttle control. Most gauges are made by Autometer, and all of them are picks by William Wynne. The oil pressure gauge is a mechanical version, no electricity involved. Instead, an oil line goes straight in the back and moves the needle directly. Gauges for voltage, current, and cylinder head temperature are electrical. The head temperature senders come with different threads than the holes in the cylinder heads. Might have tried helicoil inserts, but I didn't want to damage the heads at this point. Instead, I filed down to fit a 3/8 die. Still had a remnant of original threads when it was at the right diameter. Fingers crossed, there'll still be enough meat to cut new threads. Nope, we're not going to win this one. Glad it happened here, not later on. So, I found a pipe fitting that had more meat inside. Lucky break. The one on the left made it through being rethreaded. This'll be an adapter. Truth be told, I'd prefer a helicoil solution for safety and better accuracy, but this will work for the test run. Note the RPM range on this tachometer. Just right for the application. The sender is a magnetic coil. It creates electronic pulses from the gear teeth as they go by, and the tachometer counts them, every pulse. It has to be very close to the teeth. You barely touch them and then back off half a thread. That close, I want it rock steady. To calibrate, you count the gear teeth accurately and look up a corresponding binary code. Inside the tach is a dip switch. Set it to match the code and you're all set. Tefcell wire insulation proved to be remarkably strong, as I found out when stripping it. All the advisors specified it, along with amp crimp connectors and this design of crimping tool. No soldering allowed. Professional crimp connectors are specified throughout. So I spent a couple of days stringing wires that way. Along with gauges, I hooked up a fuse box, the voltage regulator, an automobile ignition switch, the starter button, the coil, the battery, and the starter. Of course I had to make sure it would turn. Just got to see it work once. Mounting the panel on hinges helped a lot. Looking forward to using it. Well, I couldn't see using an old oil cooler on this pristine machine, so I went for Williams' cooler of choice. Part of that changeover is blocking off the original ports, the ones the old cooler used. Got some parts to make hoses for the new cooler, and we'll get to that real soon. William makes an intake manifold custom for the Corvair. There's a little bending involved to match up with Mark's intake tubes. I bent only the stainless, not the aluminum. The carburetor is a rebuilt Stromberg. Hooking up the throttle wire, it takes a little adjusting for smooth operation. The test run's going to need some kind of cooling air ducts. I'm trying a variation on those cool-looking Piper Cub scoops. This 6061 is high temper, number 6. It's stronger than it looks. There's plenty of tapped holes already there, right where I need them. These pieces will close off the back ends. The air has to be forced down through the cooling fins. You may remember this piece from the disassembly. Both cylinder banks have one. They'll hug the rear cylinders, keeping the air flowing through the fins. The spark plug wires need a way to get in the sides without getting cut. We also need an access point to get at the dipstick. And a cover plate to retain the air pressure. Those hose parts showed up, including the hose adapter that goes with the oil hub. I'm just tightening it down now. That nut does double duty as the mounting point for an oil filter. This guy is just for the test run. I saw an EAA video on installing these filters. Once you feel the gasket touch down, they call for just another 3/4 turn. Later on, I found a right angle fitting to keep the oil pressure line laying low. The adapter also has 2 holes for a remote oil cooler, coming and going. I made the hoses with a mind toward giving the oil flow an easy path. We're going to need to be sure we're at top dead center on the compression stroke, not on the exhaust stroke. I'm using tape instead of my thumb over the plug hole. For me, it's a better way to detect the pressure. There it is. Just got to fine-tune the mark. While the plugs are still out, I'm checking the gaps. Also making sure the plugs don't stick too far into the combustion chambers. I marked the hole depth on this bent wire feeler with blue tape. Looks like the plug's threads are recessed a safe margin. That's a good thing. Found out later this copper anti-seize wasn't quite what the doctor ordered. I guess it's considered to be too likely to short the spark plug gaps. Had them all torqued in when I learned of my mistake. William recommended Champion lube, especially for spark plugs. So I cleaned and re-lubed the plugs, replaced the gaskets, and put them back in. Now I can get the plug wires on, at least on the plug end. Good to have a little slack on those wires if I ever want to take off the scoops. Getting at the hardware holding them down is a tight squeeze too. I'm replacing a few bolts with studs, setting them at a precise height so I can still get parts over them. I can get at these guys with an open-end wrench, but not with a socket. In 2 cases, I had to modify this wrench to get in there. Only reason I got the carb heat box right now was to hold a filter. Was advised to have it on the test run, which makes sense. Getting it mounted had some access issues too. Salved them with studs again. The test run gas tank is going to work by gravity feed. Brady McCormick told me how to attach the hose. You can see an inline filter there. Later on, I added a cutoff valve for safety. Getting the stand up on the trailer was easy without the engine. Added some extra support for the tongue as it looked like a weak link. Those 4 vertical bolts holding the engine, they thread right into the case. New graphite seals going on here. Brian knocked the rust off the logs in his bead blaster setup. New stainless hardware. Got those special nut locks from Clark's. Reason I'm using clear tubing here? Just want to see what's coming from the crankcase vent. Remarkably strong spring clips there. A work buddy, Joe Lewis, took my sketch and watercut these flanges. Them and a stock bent tube are going to become exhaust tubes. Another incarnation of Richard Finch's gadget helped me get new studs in the cast iron logs. Didn't see any warnings about asbestos, but I'm taking precautions. That should hold it. These new nut locks look pretty dependable. Made this wire loom from a piece of Delrin. It was a big help in marking cut lengths for the plug wires. A little silicone grease would have made this go smoother. This is the main reason I got that crimper. Brady said to go slow in this operation. Nice. Mounted the coil close, but where I wouldn't get bit. The prop's a thing of beauty. It's made for reverse rotation as the Corvair runs opposite to most aircraft engines. Very high-grade lock nuts go behind the hub. Torque spec is pretty low, 15 foot-pounds, so as not to crush the wood. I'm checking that the prop is on square to the crank. They spec an 1/8 inch max difference between the prop tips. Looks good, less than a 1/16. Don't want to forget this. That smaller container is an oil additive that older style lifters need. As every quart goes in, I'm marking the dipstick. I'm going to run the oil pump for half an hour. Williams says it's a good way to wash out the whole machine. Good way to see there's oil pressure too. Rotating the prop gives the dirt nowhere to hide. So, the rotor's aimed at number 1 plug wire, and I've moved the timing mark to 8 degrees before top dead center. Just gotta find the exact spot where the points come open. Right there. Button things up and we're on the way to the test site. It's a perfect day for a test run, and I've got some buddies and my wife on hand for the moment of truth.
Is it an 8/16?
That's a half, what you're doing there.
It's an 8/16, isn't it, Katie?
You're damn right it is.
A sticky float valve was our only obstacle.
Actually, what I would do is take it off the carburetor.
Got some helpful advice on that from a local EAA member, Neil Arney. He just came over and volunteered. The less yapping I do, the better you can take in those sweet engine sounds. Here's where you should really crank up the volume. And clear.
That sounds cool.
Okay, and clear. Scary as shit.
That's awesome. That is
really
scary.
Quite a wind machine you made.
I'm gonna send.
How many RPMs did you have?
I was at about 17 maybe. And clear. Several curious folks showed up, including more EAA members. The guy with the hat is my tech counselor, Dan Benoit. He gave the test a thumbs up.
Yeah, I've heard them talk about it, but I haven't really looked at what they did.
There was a surprising amount of interest in the Corvair conversion process.
Oh, all right. I was wondering where that came from. It's really compact.
I hope you've found the whole trip interesting. I sure have.